Okay, so now that you know a little bit about what the structure and functionality of streams are with respect to aggregate operations, intermediate operations, terminal operations, you know a little bit about the concepts of different types of aggregate operations, map, filter, and so on, collect. What I want to do now is talk about something called a splitterator. And those of you who did the grad student version of assignment 1 have had a little bit of experience with this, but we'll do a more systematic discussion of what its purpose is and how it works, or how it could work. And I'll also show you how to use a splitterator for our simple search stream. So we'll see how to implement the search for word method, and we'll see how a splitterator can be used for that. It's a very simple example. So what is a splitterator? So a splitterator is a new type of splittable iterator. That's where the word splitterator comes from. So I think there's a phrase portmanteau or something that means the combination of words to make a new word. So splitterator is a portmanteau of splittable iterator. And it combines an iterator and a splitter. So let's talk about each one. So we'll first talk about the iterator. The iterator part of a splitterator can be used to traverse all the elements in a source. So let's assume, for sake of argument, we have a list of strings, which I call quote, and we'll initialize this to be yet another classic Shakespeare quote, "This above all to thine own self be true," from Hamlet. Does anybody actually know who said that quote? Well, it's pretty obscure. It's Polonius. So Polonius is Laertes' father, and he has this whole list of sort of cliches he tells his son, and that's one of the classic ones. So let's say we have this list of strings, and we're then going to take that list of strings, and we're going to create a splitterator for it. So we say quote.splitterator. What that implies, or what I should explain to you, is that there's a splitterator method on every Java 8 collection. So list, map, so on and so forth. Everything has a splitterator that's part of it. And what this does is this creates a splitterator. And once we have a splitterator for this thing, we can then iterate through it using the try advanced method. And what that will do is it'll essentially combine the semantics of has, next, and next on an iterator, for those of you who did the array iterator implementation. And what it allows you to do is walk through every element one at a time and do something to it. So in this case, what we're going to do is we're going to pass a method reference to print out each element in the list of strings that make up our quote object. So that's what try advanced does. And what try advanced does is it returns true if there are more elements that we can iterate over, and it returns false if we're done. So you can kind of see it's combining the elements of has, next, and next. And to be honest, the original Java iterator was kind of a mess, and you can see that when you write the implementation, you have to do like sort of redundant stuff with has, next, and next. So splitterator just makes that go away. You have a single method, try advance, that will do something and return true or false if you should keep going. So it's a little bit cleaner to write and a little bit easier to use. The second part of a splitterator is the split part. And what it can be used for is to partition elements of some source. What the heck does it mean to partition? Well, this won't become really clear till we get to parallel streams, but I'll at least explain the way it works, and then you can see how we would use it later. So in this example, we're going to start by making a splitterator that's initially for the whole list of strings. So this splitterator will give us a splitterator for the whole thing. And then we're going to take this splitterator, the second half splitterator, and we're going to call the try split method on it. And what try split does is very interesting, and it's actually kind of funny when you read the documentation, which I've essentially excerpted here. It's funny because it really doesn't explain what it does when you first read it. Like, what the heck does that mean? But I'll explain it. So try split returns a splitterator covering elements in the original splitterator that will no longer be covered by the splitterator that invoked try split. So what the heck does that mean? Well, what it really means is that it will split the splitterator into two parts. So what will happen is it will return a splitterator that will cover the first half of the quotes, or the quote, and then it'll update the calling splitterator to ignore the first half and only cover the second half. So that's what try-split does. It, as the name implies, it tries to split the input up into two chunks, the first half and the second half. And ideally, a splitterator should split the original input source in half. So that's the best way to split. Now, again, it's not going to make a whole lot of sense at the moment as to why that's the best way to do it. But when we get further on to parallel streams, you'll see it's really useful if it splits it in half. And just for kicks, why do you think it's important for a splitterator to try to split the input source in half for a parallel splitterator? What's the win that comes from that? Remember we talked about parallel computing, and I told you it was a certain kind of approach to algorithms. What's it doing? Well, definitely log in time. That's right. But what is it? What's the type of algorithm that we're using here? Divide and conquer, exactly. So it's divide and conquer. Well, what better way to get the log n behavior that Vina's alluding to than by splitting the thing evenly in half each time? Because if you split something in half evenly each time, you'll end up with no more than log n splits, or log n splits. And if you look at it as a tree, and that way each chunk that you split into will be identical in size or close to identical in size. And then you can give those things after they're split down to their smallest size to a bunch of threads running on a bunch of cores, and then they can process everything. So it basically is trying to maximize parallelism, and splitting things evenly gives you the biggest bang for your buck because you end up with things that are the same size when you're done. And we'll talk more about that when we get into how the fork join pool is used in conjunction with streams. So the key point is we try to split things in half. And for something like an array list, that's really easy because, as we'll see, it's constant time to do that type of a split. Now that we've got two splitterators for the first half and the second half, we can then tell each of them, for each remaining item in your portion of the overall data source, please do something to it. So for each remaining, we'll simply say, run this method reference for everything that I've got from beginning to end. And that'll end up printing out all the first half items, this above all, vine perhaps, and this one will print out own self be true because we split it in half. Now, again, doing something sort of goofy like this doesn't really seem to make any sense at all. It'll make a lot more sense when we come back to this topic when we talk about parallel streams, because parallel streams are what use splitterators in order to be able to take an input source, like a big string, and chop it up into a whole bunch of relatively equal-sized smaller strings, and then give those relatively equal-sized smaller strings to cores that can then run together in parallel, although each chunk gets run sequentially. And we'll talk more about that later. So the key point is that splitting really is used with parallel streams. Iterator part of Spliterator is used for everything, sequential streams as well. We're going to focus on the iterator part first, and then later we'll talk about splitting. Now, the next question that's worth asking, and if you looked carefully at the skeletons for the programming assignment, you'll see kind of how this works. There's a method that's called stream_support.stream. And this helper method, which you can read about here, or here, is used to take a splitterator and use it to convert some collection into a stream. And it uses the splitterator to break the input up into chunks, and then it returns a stream of those chunks. Depending on the parameter that's passed in, called parallel, which could be true or false, it will either create a parallel stream or a sequential stream. So if parallel is false, it'll make a sequential stream. If parallel is true, it'll make a parallel stream. For the time being, we're just going to focus on sequential streams, but this is how it works under the hood. And in fact, if you go and look in the Java implementation, if you take a look at the source code for Java, and you look at the collection.java interface. So collection is an interface that's very high up in the hierarchy of things in Java. About the only thing that's higher than that is iterable. So a collection has a whole bunch of methods that all collections support. And it has two methods, stream and parallel stream. Notice these are default methods, which means that everybody who implements or derives from collection in one way or another gets these things for free. Stream uses stream support.stream, calls the Spliterator method on the collection, and then passes in false because we want a sequential stream. Parallel stream calls stream support.stream using the Spliterator method with true. So we have a parallel stream. So these are actually the factory methods that generate streams from collections. And if you look at your skeletons for the grad students, I provided you with these methods, and that was how we used the Spliterator to break things up. Okay, so now that you know a little bit about what a Spliterator is trying to do, let's see how we could actually apply it. And so what we're going to do is we're going to use a sequential Spliterator in order to be able to do the search for word method. So remember, search for word is the method that's used to find all the instances of a word in our list of words we're looking for, like do, re, mi, and so on. And it returns a list of all the search results corresponding to that word when looked up in the input string. So the key things that we have here are the input string, the word, and we want to get back this search results data structure. So this is where it occurs in the stream, and here is where the search for word method is defined. It's defined in the word searcher class. And I'm not going to show you all of the code, but I'll just focus on the key parts here. So search for word, it takes a string, which is the word we're looking for, and under the hood, it makes a new search results object, which is what gets returned here. And that search results object will contain the input string, the word we're looking for, something called the title, a few other things. And then, most importantly for this discussion, it says stream support.stream new word match splitterator, which is then going to take the input string and the word we're searching for, and it will create a sequential stream whose contents indicate all the places in the input string where this particular search word occurred, the index where it occurred. And notice we get this, we run this thing, search support.stream returns a sequential stream, which we then collect into a list, and we stick it as the last parameter in the search results constructor. So what it's doing is it's saying, take the input string, take the word, make an object that contains the word we're looking for, the input string we've got, and a list of results where that word was found in the input string. So it's kind of cool. It's really neat. So we're using the stream support.stream method to create a stream. We're using the word match splitterator, which we'll talk about in a second, to do the breaking up of the input. And then we're taking that stream, turning it into a list, and stuffing it into the search results object so we can get to it later. Okay. This is word match splitterator. And another reason why I'm explaining all this stuff is you'll get a chance to write your own containers later. And so it's important to kind of know how these things work. So word match splitterator extends splitterators.abstract splitterator. Abstract splitterator is a little helper abstract class, as the name implies, that does a bunch of stuff for you so you don't have to fill everything in. And here is the list of fields and the constructor. Here's a field and the constructor used to implement word match splitterator, which you can find here at this link. So this contains a single parameter called mWordMatcher, which is a matcher. This is just a Java regular expression matching capability. I'll show you how it's used in a second. And here's the constructor. The constructor takes the input string and the word we're looking for, and it takes the word and it trims off any leading or trailing white space. And then it inserts a regular expression bound that basically says this is to be used to only match words that are words, not words that are substrings in a bigger word. So it'll only match on word boundaries. That's what the \\b means. So it's a boundary. So we're bounding this thing to just look for a word. It's a regular expression that just matches a word as a word, not a word as a substring. And then we take that regular expression and we compile it, and we tell it we want to be case insensitive. We don't care if it's capitalized or not. We get back a compiled regular expression, and then we take that compiled regular expression and we create a matcher from that compiled regular expression that will apply the regular expression to the input. And the input, of course, is the input string we're going to search the word in. Okay, any questions about that? So now we've got a regular expression matcher that knows how to find cases of this regular expression word in the input string. And finally, the cool part, the try advanced method. So try advanced is automatically called back by the Java Streams framework, in particular by the stream support.stream method we saw, the factory method that creates a stream. And what it'll do is it's called back in order to be able to try to advance the splitterator by one matching word. So try advance, it takes in a consumer. Remember we talked about consumer before? And the consumer is going to be used to pass back a match if there is one. So you'll see how it gets applied in a second. So this is basically used as a pass by reference parameter to get the next item back to the streams framework if there is a next item. How do we know if there's a next item? The first thing we do is we say, hey, word matcher, find me the next match of the regular expression you were given in the input string you were connected to. If there is no such match, that means we're done, right? There are no more matches to be found. There may never have been a match to find at all, but we know that there's no more. So if we get a false here, we just return false. So that says to the streams framework, we're done. Don't do anything else. Finish with what you had at this point, if anything. However, if find does not return false, that means there was a match. And then we simply say, hey, word matcher, where did that match start? Tell me the index where that match began. And so we make ourselves a new result object, which will have the index where the match occurred. And we take that new result object and we accept it into the consumer action. So that'll be stashed away and then returned back to the streams framework, so it can keep track of that. And that'll be used to create the elements in the stream. And we also return true, just saying, keep trying. And we found a match. There may be another one, so you got to try again. So here's kind of how this looks. If you take a look, we had a stream of words, which were the search words for our input string. We called search for word, which took each word and tried to find it in the string. And as you can see, map will return a stream of search results where search for word created each of those search results on each of the input strings we were searching for here. Each of the search words we were searching for with respect to the input string. Okay. Any questions about any of that stuff? All right.